This lectures cover introduction to supervised learning, one of the machine learning tasks. So we mentioned earlier, machine learning is a branch of AI or artificial intelligence that enables systems to learn from data and also improve their performance over time without being explicitly programmed. So our main objective is to go through what is a supervised learning. So supervised learning again is a type of machine learning where the algorithm is trained on a labeled data set, also called training data set. This data set also have what we call the target variable or the class link. So for example, we are predicting if a patient have a disease A. Here we know we have patients that have that disease, and we know the target, whether it's yes or no, they have the disease. So it's a labeled data set we are going to use to build a model first. So again, example given here also predicting a house price, mail spam detection. So again, supervised learning is a fundamental approach for machine learning and artificial intelligence. It also involves training a model using the labeled data. So over time also, it adjusts itself to minimize the errors and improve accuracy. Now, we have types of supervised learning in machine learning. First will be the classification, here where the output is categorical variable, as we said earlier. For example, spam or no spam, yes or no, true or false, etc. So for example, classification model might be trained on data set of images labeled as dogs or cats, and it can be used to predict the class of new and also unseen images, whether it's a dog or cat, based on their features such as color, texture, and also shape. We also have some types of classification, two types of classification. One is the binary classification and also multi-class classification. In binary classification, the output will be two. So we say that's the simplest kind of classification. In binary classification, the goal is to sort the data into two distinct categories. Now, with multi-class classification, the data need to be sorted into more than two categories. So again, binary classification is the simplest kind of classification. So in binary classification, the goal again is to sort the data into two distinct categories. We can think of it like a simple choice between two options. Imagine a system that sort email into spam or not a spam. Also, it works by looking at different features of the email, like certain keywords, sender details, and decide whether it's a spam or not. It only chooses between these two options. Then the multi-classification. Now, instead of just two categories, the data need to be sorted into more than two categories. So the model picks the one that best matches the input. We can take off an image recognition system that sorts pictures of animals into categories like cat or dog and bird. So how does classification in machine learning works? Here we say classification normally involves training a model using a labeled data set where each input is paired with its current output label. The model learns patterns and also relationships in the data so that it can later predict labels for new or unseen inputs. So in machine learning, classification works by training a model to learn patterns from labeled data. So it can predict the category or class of new unseen data. So for example, here are how again it works. First, we have data collection. So we start with a data set where each item is labeled with correct class, for example, cat or dog. Then we move to the feature extraction. In feature extraction, the system identifies the features such as, let's say, the shape, color, or texture that help distinguish one class from another. So these features are what the model uses to predict or to make predictions. Then the next step will be the model training. So classification, machine learning algorithm uses the labeled data to learn how to map the features to the correct classes. And also it looks for the pattern and relationship in the data. Then we have the model evaluation. So now once the model is trained and is tested on new unseen data to check how accurately it can classify the items. Then we have prediction. After being trained, evaluated, the model can be used to predict the class of new data based on the features it has learned. And lastly, the model evaluation. So evaluating a classification model, I would say, is a key step in machine learning. It helps us check how well the model performs and how good it is at, again, handling view or scene. So again, depending on the problem and needs, we can use different metrics to measure, again, the performance. So example of machine learning classification in real world. So classification algorithms are widely used in many real-world applications across various domains. This can include the email filtering system or credit risk assessment, medical diagnosis. So in terms of credit risk assessment, the algorithm predicts whether a loan applicant is likely to default by analyzing the factors such as credit score, income, and loan history. So this helps banks make informed lending decisions and also minimize the financial risk. Now, with the medical diagnosis, we say machine learning models classify whether a patient has a certain condition, cancer or diabetes, based on the medical data such as test results, symptoms, and patient history. Now, this is the doctor in making a quicker and more accurate, or say more accurate diagnosis, also to improve the patient care. With imaging classification, we can say this apply in a field such as facial recognition, autonomous drive-driven vehicles, medical imaging. Then we have the sentiment analysis also, as we said, determine whether the sentiment of a piece of text is positive or negative or neutral. Then fraud detection here, algorithm will detect fraudulent activities by analyzing transaction patterns and also identify anomaly, crucial in protecting against credit card fraud and other devices. So classification modeling in machine learning. Let's see the key characteristics of classification model. We have the class separation, decision boundaries, sensitivity to data quality, handling imbalanced data, and also interpretability. So first is class separation. Here we can say classification rely on distinguishing between distinct classes. The goal is to learn a model that can separate or categorize data points into, again, a predefined classes based on their features. Now, with decision boundaries, we can say the model would draws decision boundaries in the feature space to differentiate between classes. And these boundaries can be linear or non-linear. Then sensitive to data quality. Here we say classification models are sensitive to data quality and also data quantity of training data set. So a well-labeled representative data ensure better performance, while noisy or biased data can lead to, again, poor predictions. Classification problem may face challenges when one class is underrepresented. So special techniques such as resampling or weighting are used to handle class imbalance. Then lastly, the interpretability. Some classification algorithms such as decision tree offer higher interpretability, meaning it's easier to understand why a model made a particular, again, prediction. So next will be the classification algorithms. Now for implementation of any classification model, it's very important to understand logistic regression, which is one of the most fundamental and widely used algorithm in machine learning for classification tasks. Also, there are various types of classifiers algorithms. Some of them are, again, let's say linear regression or logistic regression, support vector machine, single layer perceptron, gradient descent, etc. Then within the nonlinear classifiers, here we can see that a nonlinear model creates a nonlinear decision boundary between classes. So again, nonlinear models will create a nonlinear decision boundary between classes. And they can capture more complex relationship between inputs. So again, we also have k-nearest neighbor, kernel, support vector machine, decision tree, assembly learning. Assembly learning can be the bagging and boosting, other boosts, etc. So we shall go through all these algorithms as time goes on. So first we start with regression. Here we say regression where the output is a continuous variable. This is the key difference between regression and classification. The output variable, the target variable, is always must be a value. So regression in machine learning refers to supervised learning techniques where the goal is to predict a continuous numerical value based on one or more independent features. Also, it finds relationship between variables so that prediction can be made. So we have two types of, again, variables present here. We have the dependent variable, which is a variable we are trying to predict. Example can be the stock price. And also dependent variable. This will be the input variables that influence the prediction. Example, locality, number of rooms, etc. Now, types of regression also, we have many types. For example, simple linear regression, multiple linear regression, polynomial regression, ridge and lasso regression, support vector regression, decision tree regression, and also random forest, again, regression. So with linear regression, is one of the simplest and most widely used model. This assuming that there's a linear relationship between independent and the dependent variable. So this means that the change in the dependent variable is proportional to the change in the independent variable. So for example, predicting the price of a house based on what? Multiple features. It can be location, the size, and also number of the rooms. Then we have polynomial regression. Normally it's used to model with non-linear. We know polynomial equation is non-linear. Relationship between dependent variable and independent variable. It adds, again, polynomial terms to the linear regression model to capture more complex relationships. Also, we have the ridge and lasso regression. which are a regularized version of linear regression that help avoid overfitting. Then support vector machine is a type of regression algorithm that is based on support vector machine, support vector regression. Then we have decision tree, which uses tree-like structure to make decisions where each branch of tree represents a decision and the leaves represent again the outcome. And lastly, we also have a random forest regression, which is a sample method. We also have bargain and boost, other boosts, etc. So regression evaluation metrics. Here we see evaluation in machine learning measure the performance of a model. So here are some popular evaluation metrics for regression. We have the mean absolute error, which is the average absolute difference between predicted and actual values of the target variable. We also have the mean square error, which is the average square difference between the predicted and actual values of the target variable. We also have the root mean square error. That will be the square root of the mean square error. Then we have Hubbard loss. Hubbard loss is the hybrid loss function that transitions from MAE to MSE. Again, that's a mean absolute error to mean square error. Then we have R2 score, which is higher value indicate better fit ranging from 0 to 1. Next, we talk about the application of regression. Again, as we said earlier, with regression, our target variable is always a value, a numerical value. So example, predicting a price of stock or items, forecasting trend, identify risk factors, and also making decisions. The advantage and disadvantage of regression, first, is easy to understand and interpret. Also, robust to outlines, and also can handle both linear relationship very easily. Disadvantage is that we always have to assume linearity for again, and also sensitive to situations where two or more independent variables are highly correlated with each other. This is the concept of multi-coloniality, which we're going to discuss in the future. Also may not be suitable for highly complex relationships. So this will be the conclusion of our lectures. Again, if you have a question, send an email and see you in the next lectures.